Now today we're going to look at the second type of projection. So far we have done ground to ground, where we start with ground at an angle, it goes up, reaches maximum height, then comes back down, and the actual path, the trajectory of the path is very symmetrical. And remember, we are always assuming that there are no air resistance and the gravity always stays at 9.8. Now, a horizontal projection is famous because it's where you project sideways. In other words, something that might roll off a desk. So if it goes forward, it leaves the desk and then starts to fall. And in reality, what it does is it goes through a trajectory which is just the half of the travel that we have for the ground to ground. Okay? So we're really starting up here at maximum height. But we treat this projection totally different than a ground to ground. So you go, okay, ground to ground, I do it this way. Horizontal projection, I do it slightly different. So, firstly, let's have a look at some of the features of a horizontal projection. The projection angle, firstly, is 0. So, it's projected off here at that angle there. Okay. This means that when we do our little triangle, now remember the triangle is what is called resolving. If that is u, then this is u sine theta, and this is u cos theta, where that angle there is theta. If theta equals 0, what does sine theta equal? What is sine theta if theta is 0? 0. You should know that both by mathematics. All of you are 2 or 3 in mathematicians here. That should be off the top of your head. So if theta is 0, then u sine theta becomes 0. What is cos theta if theta is 0? This is once again an exact value. You must know it. It is 1. So if cos theta equals 1, then ux would equal u. Because u cos theta, remember u cos theta is ux, it's u times 1, so ux would equal u. So the projection velocity, which is u, is the same as the horizontal velocity, which is ux. So this means that we automatically know some values to start with. So we know that u equals ux. We also know that uy is equal to 0. The initial vertical velocity is 0. It's when it rolls off the desk, when it is first projected sideways, it's neither going up nor down. Is that clear? In a horizontal projection, we project it both sideways and initially up. Here, there is no up push. It is simply a off the bench. And then first motion is it starts to go down. So it goes sideways and down. That's the only options it's got. We always take the origin as here. This is the origin point. That is 0, 0 in our coordinate system. That means the ground here is at a negative value. This is still a projectile motion. So the sideways motion is always going to be simply a constant sideways motion at ux, just like the other one. So range, which is this here, that range is that distance there, is how far it falls from underneath the original's projection points. Range is always how far it moves sideways. And range is still given as ux times the time of flight. Okay. Are we okay with that? However, the time of flight is going to be much shorter. We don't need to do anything like doubling it like a ground-to-ground projection and so on. The time of flight is just how long it takes to fall straight down. Okay. So the time of flight is measured until the projectile hits an object. In this case, it's mostly the ground, or in most other cases, it could be the water or the ocean. Okay. Are we okay with all that? If we're okay with this idea, then we should have no problem with going back and having a look at this. Now, I need to do one little correction here. When I printed this, it says here in, this is question 2 of worksheet 2B, it says UX equals UX, which is mostly useless, okay? It meant to be U equals UX. So if we just get that little subscript on the first X, can we all see where that error is on worksheet 2B? Okay. Right, so this is just, once again, before we get into actually doing some real big work with all this stuff, we have to do some repetitive, let's get our ideas, okay? So let's go through here. Number 2 says complete the following table for the various values of horizontal projections at certain heights above the horizontal. Sorry, I can't pronounce it. No. So this H here is the height above the ground. So we can pretend that we're throwing something off a cliff, but when we're throwing it off a cliff, we're only pushing it exactly sideways. We are not throwing it up and then down. Okay? And we're not pushing it down. We're just rolling it off a cliff, off a desk, off a bench. Are we okay with the projection? Right. So let's now work with that. So we'll just go to the first one together. The projection velocity here is 500. So we've got U equals 500. Now, because it's a projection horizontally, what do I know about U and UX? They're the same, so we can automatically write 500 in there. Okay? Now, horizontal projection, ground-to-ground projection, and the next one, which is the partial projection, are all the same. Once you can do one, you can do them all. So it's just going to use our UVART system, and we are going to find H now. So I want UVART. Now, when we are doing this, these UVARTs only refer to what motion? It's the Y motion, the vertical motion. So that's the reason why we always subscript them with Y. And so that little scribble that you can see there are Y's. Okay. This is 100. So therefore, we are seeing that this value here, the height of the cliff, the height of the desk, is 100 metres. Are we okay with that? And it's just rolling it off at 500 metres per second. It's a big roll. Okay. How far will it take to hit the ground? How long will it take? Okay. So, if we start with UY, what do I know in a horizontal projection automatically UY equals? What is UY? It's a set value. 0, because theta equals 0. There is no projection angle. In other words, it's not projected up. If theta equals 0, sine theta equals 0. Therefore, UY must automatically always, no matter what, without exception, equal 0. Excellent. We don't know the velocity that it hits the ground at. Okay? But we know the acceleration is negative 9.8. We know the distance that it's going to fall vertically through. What is the distance it's going to fall through? 100. So remember, Ry is a vector, and this is below my origin point. So what will Ry be? Negative 100. Excellent. And this is what we want to find, the time for it just to fall. Looking at those values there, what equation will I use? Right, it's the R equals UT one. The one we don't like using because it often falls up, or gives us a quadratic if we're finding time. And we're finding time. But one beautiful thing which will happen is once we start using it, you go, yes, it's this 0 which is going to be our friend. Okay? So looking at the formula, which is r equals ut plus a half at squared, and these are all subscripted with y's. R is minus 100, so popping in that value there as minus 100. U is beautifully 0. So it's 0 times time, which we're trying to find, it goes away, plus a half, negative 9.8 times t squared. Remember, t is what we're trying to find. Sorry, I'm running out of room there. I'll just keep on going, as you can see, hopefully. So you get, I'll go into red, so you can probably see it, minus 100 equals negative 4.9 t squared. Now, this is always going to happen. Because acceleration is negative, you'll get a negative over here. And because it's just dropping straight down, it's also moving sideways, you'll also get a negative. What will happen to the two negatives? Cancels. That means we can take a square root now. So we get t squared equals 100 divided by 4.9. That's approximately 5. So it's going to be about the square root of 20. And that gives us t equaling 4.52. Okay? So the time of flight is 4.52 because remember, time of flight is defined as the time that it's in the air. Okay, before it strikes something. Okay. Now range is always ux times the time of flight. So we know that ux is 500, and don't forget that the projection velocity, because it is horizontal, we've classified this motion as horizontal projection, that u, the projection velocity, and ux are the same. So to find the range, we simply multiply these two values together. So 4.52 times 500, 2,260 metres. Okay? Okay. Are we okay with this calculation? Rightio. There are another 5 for you to practice on while before we go on to the next bit. Okay, off you go. Once you've completed that that little question there, 2A, you can then go down to do 2B, and here it's on the 2 pages, so yours is only 1 page. This is a proofing document. This one here says, by working backward, determine the height of the projection. So it's leading you that we already know the horizontal velocity there as 420, and I'm giving you the range. So what would I use to find the time of flight? Good, excellent. We use the formula that range is equal to ux times the time of flight, and therefore just division of those two values will give us this. Okay? Once you've done that, by working backwards, using the formula ry equals uyt plus a half ayt squared, remembering what do I know as ry? That is 0. So, did I say ry? uy. You know uy is 0. So that term in front there always drops out. And we are left with just ry equaling this. So we want to find ry, which is the height, isn't it? Now, what is the difference between ry and height? Right. Height is actually negative ry. Okay? Because we're talking about height as a real value here, and ry is a mathematical depiction of where it is in reference to the origin, isn't it? So I want to take a few moments now and do B, please. Okay, I'd like to add one more concept to our projectile motion. This applies to all projectile motion. It doesn't just go for the horizontal. motion, the horizontal projection that we're doing at the moment. This is the velocity at any time. Now, when we are first projecting an object, we project it at an angle, which is theta, at a velocity u. And we know that we can separate this diagonal motion into two motions. One, firstly, as ux, the initial horizontal velocity, and then another motion, which is uy, the initial vertical motion. And we know that this is u cos theta and u sin theta. And you've already done the process that you've worked these values out, and you can come back to finding u. How do you come back if you know ux and uy? How do we re-establish what was the projection velocity? Sorry? Trigonometry or Pythagoras. Exactly. And we're going to just simply use Pythagoras. Now this is done, this one over here is the initial velocity. That's what we already know how to do. We're now going to apply this to at any time. What is my velocity at any time? Well, at any time, so writing this there, this is the velocity at any time. Okay? Now, at any moment, this particle, this ball, this cannonball, this whatever is being projected, is moving in a vertical direction, either up or down, and sideways, isn't it? So that means that at any moment, this is the direction that we're moving. It's moving sideways as well as moving up. So to put it back together to find out what is my total velocity, I just use Pythagoras. And to find the hypotenuse of a right angled triangle, you simply square both of its sides and then add them together and square root, don't you? So this is what we're doing here. We're finding V as the hypotenuse of a right angled triangle by squaring the other two sides and then taking the square root. Are we okay with that? So to make sure I understand what we're doing and why we're doing it, at this moment here, let's put this diagram in the centre a bit. This particle here, at that yellow ball, is moving in two directions. It's moving up at Vy, and it's moving sideways at Vx. Now, we know that Vx doesn't change. It's the same as Ux, doesn't it? Because the horizontal motion is constant. But what we want to know is not what it's doing sideways or vertically. We want to see what it's doing in reality, the combined motion, which is this vector here. So that white vector there is the addition of the other two. And so we add vectors together, we use Pythagoras. It's also moving at a certain angle, reference to the ground, and if you think about it, in a right angled triangle, then we just simply need Pythagoras. Sorry, not Pythagoras. We need the right colour. If that's theta, then tan theta is opposite over adjacent. So there's the opposite over adjacent. So it's Vy on Vx. Okay. Also put yourself a note that Vx is always the same as Ux. And the HSC gives you a formula to remind you of this. It writes V squared x is U squared x. I don't know why they actually put the squares in really there. They don't even need to do the squares. But it's because of this. We want that there is the same as U squared x. Okay? This moment. Okay. Now, if tan theta is positive, we're on the way up. If tan theta is negative, we're on the way down. Now, how can tan theta become negative? It becomes negative if this simply becomes a negative Vy. In this case, going to this diagram over here, going back, I wanted to clear annotations instead. Go to this diagram here. On the way down, the particle still moves sideways with a constant velocity. Notice this Vx here is the same as this Vx here, because the horizontal motion is, what C word? Constant. Good. But on the way down, the vertical motion has changed because the ball is moving vertically down now. So you'll notice that the addition, the right angle, the hypotenuse, that line there is now pointed at an angle downward. That line is measured by, the length of that is by the hypotenuse, so we use the square over here, the square root one, that formula there. And the angle becomes a negative because it means that we are now moving at an angle below the horizontal. Okay? So that's the horizontal, that's always 0. So theta being 0 means we're moving, negative means we're below the 0. Are we okay with that? Yeah? Now, to ram this all home, I've given you a sheet called Projectile Motion Projection, horizontal projection, and we're going to work our way through one, and then you're going to try your best to complete it. Okay, have we all got that there? Once again, you need to fill out that table. There's less to do this time, but there are more columns. And the V on impact column is mu. Also, V at 3 seconds and H at 5 seconds is also mu. Okay, so let's go through it. Right, question number 1. So let's write down all of our data. A lifeboat is dropped from a plane moving at 140 metres per second. So here's our plane. It's moving this direction at 140 metres per second, and it's going to drop a lifeboat. And once the lifeboat leaves the plane, it's going to go through that shape there, which is parabolic. Are we okay with what's going to happen? So the pink path there is the trajectory of the lifeboat. And it will hit the water. Hopefully it's going to hit water, otherwise the boat's not very useful. And the height here above the ground is 1,002.5 metres. Okay? So remember, when filling out this table, you don't have to fill it out in order, because once you get going with this, you'll have it all over the place. So what is U? Here's 140 metres per second. That's the projection velocity, isn't it? That's how fast the lifeboat was released. Okay? What would be UX? Right, 140 metres per second. Why is that the case? Right, because UX equals U in a horizontal projection. And I think we're all agreed, because we're doing a sheet called horizontal projection, and as we diagram, it says it's horizontal projection. What is UY? 0. Why is that set automatically to 0? Because it's horizontal projection, and theta is 0. Good. We're starting to play the game. Right. The next is we want to find range. To find range, I need UX times the time of flight. The problem is I don't know the time of flight, so let's do time of flight. I think that's a few columns along. So, to find time of flight, we use our U-bar. Right, UY is 0. We don't know the vertical collision with the Earth, the velocity it's going, but we do know it's negative 9.8 acceleration downward. RY is, what's wrong with that value? Right, it's next to being a negative because this position up here is the origin. Good. And t is what we're trying to find, time of flight. Okay. We also know that we're going to be using this formula. But what's going to happen to this term here? It will go, because that becomes 0. So we don't even have to shove in that part. So it's negative 1102.5 equals, now you should realise these values. What is a half of 9.8? 4.9. So that would be negative 4.9. It just makes it easier if you, sorry, this should be a square up there, yeah? If you know that. What happens to those two negatives? They cancel. What would happen if they didn't cancel? Right, something's been wrong. Something's gone wrong. And the most common thing that you wouldn't have realised was that that should be a negative there. So remember, the mathematics prompts you that you're wrong. Okay, this should lead you to solving that. We get t equals, what's the t value here? 15. Is it 15 exact?
Yeah.
I think it's designed that one. Right, so now we've got the time of flight. So we can now go back into our range. Our range would equal 140 times 15. 2,100 metres. So this distance here is 2,100 metres. Okay. Right here. The next column along is the Vx column. What can I write with Vx? Right, it's 140, isn't it? Good, excellent. But there seems to be a lot more columns, but a lot of those columns are the same, aren't they? And one column you can write down totally is just 0. Okay, why is that? Why is Ux equaling to Vx? Or as the HSC wants to tell you, that Ux squared is Vx squared. Right, constant motion of the horizontal motion. Yes, the horizontal motion is constant. That was, yeah, that was very taught to us. Okay, now we want to find Vy on impact. Now, Vy is how fast it was moving downward when it strikes the ocean. Okay? To find Vy, this is the one that we're trying to find. So let's go to our UVART system again. Rightio, got my presentation. Now, what is Uy for all of this motion? 0. This is what I want to find. Okay. What is Ay? Negative 9.8. What is Ry when it strikes the ground? Negative 1102.5. Do I know the time of flight? Yes, it's 15 seconds. Now, once again, this is a calculated value. You are free to use it, but I would avoid using it just in case you have made an error. So let's use the stuff which is printed. What formula is suggested by those values? Good, excellent. V squared equals U squared plus 2AY RY. Right, yeah? Or delta Y. Remember, don't forget that there are two ways that RY can be done. The reason why I like RY is it makes the word UVART. Okay? Shoving in the numbers, this is what we're trying to find here. Okay? So Vy squared equals 0 plus 2 times negative 9.8 times negative 1102.5. So Vy squared equals 20,609. Now, 21,000. Yeah. Now, we need to do what to do this? Right. Now, Vy squared would equal plus and minus this time. Normally you would go and worry about this, but this time we know what is this object doing. It's going down. Are we okay that it's going down? So I know I only want the negative one. So you really don't need to do a plus or minus. So why don't we just say this equals negative, could I just square root that please? 147. Just write Vy is less than 0 because you know that. Okay? So if you're ever finding Vy here, you've got to use common sense, because when you square root, you will get a plus and minus value at this stage here, and you say, okay, am I on the way up or am I on the way down? Okay? Right, so I've now got Vy. I want to find V on impact. Well, V on impact would equal the square root of Vy squared on impact plus Vx squared on impact. Okay? So that's at impact, and we want this value here at impact as well. Right, so do I know Vy on impact? Yes, it's negative 147, and we need to square it. So there is our saviour. We don't know it's a negative, it will be squared and plus positive anyway. What do I know Vx is? It's the same as Ux, which is the same as U, so it's 140. Oops, I've square that. And what is the value for that, please?
203.
Sorry?
200.
203 metres per second. Now, even though it's not asked for it, we're going to do it anyway. What is the angle it digs into the ocean at? This is the angle of impact. We want to find theta. So tan theta would equal Vy on Vx. Now this time we definitely need to know that that's a negative, because it's a negative angle. So it's negative 147 on 140. So that's negative 1 point something. Shift tan, you'll get theta equaling negative
46.4.
Yeah, 46.4 is it? So we'll just say 46, 1 dp. So what does that mean? It means as it strikes the ocean, it's travelling at 203 metres per second, and the angle that it's going in is at 46 degrees. Is that making sense? Yeah. Right, now, sorry, what was that? Yes, it's very fast. If that was a human, you'd be flayed. Do you know what flayed means? Your skin gets stripped off your bones. Okay. That's just why people who jump off the Harbour Bridge don't survive. They can survive the fall, but their skin gets stripped. It's terrible. Okay, right now. H. Height. Height is negative Ry, so it's 1102.5 metres. Okay? Not all their skin goes, it's just you've got to remember, jumping from that height, the oceans, because of surface tension, would be like jumping onto rock. Okay, now, we'll come back to the last two columns. Okay? We'll come back to the last two columns tomorrow. So I want you to overnight do your best to try and do questions 2, 3, 4 and 5. Tomorrow we will be going through the rest of this, plus we will go back onto that other sheet which is 2B. Okay? But I don't want to set too much, otherwise if you can't do one then you're stuck for a whole lot.